Okay.
Could we do like number 26?
Number 26 in chain rule.
Mm-hmm. On page 3.
Okay. So we have, okay. So this is what just for everyone else, what I'm doing is I'm using Microsoft Whiteboard. I'll send the link in the chat. You can either, that's weird. You can either go to Microsoft Whiteboard later, or you can just follow my screen share right now. And then if you want to hop in and explain something because you feel confident about it and you want to just try explaining it or go as much as you can, feel free to do that. And then that way we can have a record of everything we're doing on here. Okay, all right. So let's look at number 26. Okay, so for number 26, we have y equals e to the 3x, right? Divided by natural log of e to the 4x squared. Okay. Right off the bat, I'm going to simplify this. Okay, so what does the denominator equal? What should I do the denominator? What do you guys think? What can I do to this denominator?
Move it to the front, or move the 4x squared to the front.
Okay, all right. So this is sorry. I mean, it's not your fault or anything. I just want to clear this up. So yes, what you are doing is you can think of this as an exponent, bring it forward, and then you know natural log of e is 1. But this isn't the way you should be thinking about it, I should say, because the better way to think about it is just think, okay, I'm taking the natural log, I'm taking log base e of e to the something, right? When I think of log of something, that means they're inverse functions. So you don't even need to think about, okay, bringing it forward, none of that. Just think, okay, if I'm taking the inverse, or if I'm taking the natural log of e to something, then the question is, when I take natural log, that's e to what power equals this? And obviously, e to the whatever's powers up here is going to equal e to that power, right? So this is just 4x squared. Since these are inverse functions, you don't need to worry about that. Okay. So we have 4x squared in the denominator, and then in the numerator, of course, we have e to the 3x. So there's two ways we can approach it. One is power rule. So if I wanted to use power rule, I would write this as 1/4 e to the, it's not power rule, I mean product rule. 1/4 e to the 3x times x to the negative 2. Or I can use quotient rule using this. Which route do you guys want to take?
We can just do the product rule.
I always prefer a product rule just because we don't have to deal with denominators, so I always prefer that. So, all right. So the derivative of the first function would be what? 1/4 e to the 3x, right? Because the derivative of e to the x is just e to the x. And because we have to take the derivative of the inside function, the derivative of 3x is just 3. So really then, instead of 1/4, I can just write a 3/4 here, right? So 3/4 e to the 3x, x to the negative 2. I'll clean this up later for you guys. And then plus the derivative of the second function. The derivative of the second function is negative 2 x to the negative thirds, right? So I can write this as minus 2 times x to the negative 3 times 1/4 e to the 3x, right? And obviously I can write this nicely. If I wanted to write it nicely, I would say this is 3e to the 3x over 4x squared minus, let's see, this will become 1/2. So we'll have e to the 3x over 2x cubed. Let me have my work open in front of me just to check, because I don't want to lead you guys to the wrong answers. Is this what you guys got, or does this make sense in general?
Yeah.
Okay. Cool.
I think I just need to do some practice with like e and ln just a little bit more.
Sure. 6. I got negative e to the 3x over 2x cubed plus 3 e to the 3x over 4. Perfect. Exactly. All right, good. Anything else?
I don't. So, I mean, if no one else has another question, could we do another one?
Yeah, of course, of course. That's interesting.
Oh wait, I was confused about 29.
Okay, yeah, sure. So number 29.
Maybe it was. I don't know. Like I don't know. Never mind.
These, yeah, I know what you're talking about. These can get confusing. So number 29 is y equals. Sorry, I just blanked. Y equals 2x e to the 2x squared plus 3. So once you start doing this, it's a lot of brain work rather than writing stuff out. You got to get comfortable doing stuff in your brain after a while. So, I can just write dy dx as what? Well, it'll be the derivative of the first function is what? I can think of this as two functions, right? This one and then this one. So the derivative of this one is 2 times the second function, e to the 2x squared plus 3. And then I can add this function's derivative times this function. So I'll just put the 2x out front. Now, the derivative of this one is just what? E to the 2x squared plus 3. Then we do the derivative of the inside function. So this is right here. Our numerator up here is not numerator. Our exponent up here is our inside function. And what's the derivative of the exponent?
4.
Exactly, 4x. So we get dy dx is equal to 2e, the 2x squared plus 3, plus 8x squared times e to the 2x squared plus 3. Now, what some people might do, I don't know if I did it in mine. No, I didn't do it in mine because I personally don't like to do it because it's kind of like going a step backwards. But sometimes if you're like actually testing it out with real numbers, sometimes you might want to factor it just to make your calculations a little easier. So factor out the e to the 2x squared plus 3, and you'll get 2 plus 8x squared. Okay?
Okay. I think she got something different in the solutions, which is why I was really
So a lot of the solutions were different, and I know some of them were wrong. So I kind of just didn't stop looking at the solutions after a while because sometimes they get, they cause unnecessary doubt in me that I don't want to have, because otherwise then I lose confidence in my answer. But what does it say in the solutions for this one?
It says 2e to the power of 2x squared plus 2 times, like parentheses, x squared at 8x squared plus 1.
MG, I think I got the same answer as the key because I was doing it her dy over du, du over d. So like that, like, how she was like using the method to.
Yeah, but it's the same. It should always be the same. I mean, what I'm doing is I'm just doing it in my head, and it should be the same answer.
Then maybe she like moves some numbers.
Okay, so hold on, Alina, could you say the answer in the solutions one more time?
So it's 2e to the power of 2x squared plus 3 times, in parentheses, 8x squared plus 1.
Oh, I'm sorry. So first, well, we did this correctly. I think. Let me just look over this one more time. Derivative of this one. Derivative of this one times e to the 2x squared plus 3. Good. Plus the derivative of this one times 2x. So the derivative of this one is e to the 2x squared plus 3. 4x. Oh, this is right. This process we did is right. I made a silly mistake. Is when we were factoring, I should have factored out a 2 with it. So it should have been 2 e to the 2x squared plus 3 times 4x squared, 1 plus 4x squared. So this should still be a 4, but then it would be correct, I believe. Unless I did something wrong. Does this look...
It looks right. I'm pretty sure it is.
Yeah, it looks right, okay.
Okay.
Um, MG,
Yeah.
can you explain 15 on implicit differentiation if there are like no more problems for chain rule?
15 on which one?
Implicit differentiation.
Sorry, which one?
Implicit differentiation.
Implicit differentiate. Okay, okay.
I talked about
I'm
it.
sorry. 15. That's one of the multiple. Oh, I had a fun time with this one. A really, really fun time. Meaning, like, I kept doing the same thing over and over. I'm like, why can I not find the answer? So when you have multiple choice, you want to push your. Okay, you want to push. Okay, all right. Bye, Alina. Thanks. You want to push your answer to one of the answer choices, if that makes sense. So.
Okay.
Okay. So this is.
What you mean.
Oh, I did not mean to do that. So this right here is. Hold on. Let me make it a little bit. This is chain rule right here. And then we want to go over here and let's look at implicit differentiation. Okay, all right. So for implicit differentiation, we're looking at number 15. So we have when an object is placed at a distance p from a convex lens. Okay, you don't need really, it's good to visualize that, but for the sake of this problem, since they give you the equation, you don't really need that. So we have 1/5 equals 1 over p plus 1 over q. All right. We need to find dp dq, right? So we're trying to find dp dq, and so originally what I did was, I think what I tried to do was I tried to differentiate both sides, but that, like, no matter what you do, it doesn't end up working. Let's think about this. What are some ways to, so like, here's what I'm saying. What you would end up with is you would end up with 0 equals negative 1 over p squared dp dq, minus 1 over q squared. And no matter what you do, you won't be able to push it into one of those forms where it's 25 over q minus 5 whole squared. So, you know what? I have to look at what I did, because at the moment I can't think of the best way to do this. I know I spent a lot of time doing this and going back and forth between different methods, and finally I remember I was able to figure it out. But let's see. Okay. I know why. So this is one of those problems where you have to, instead of doing this, what you want to do is you want to solve for p first. Okay? So what we're going to do is we're going to say 1 over p equals 1/5 minus 1 over q, I believe. Yep. And then what we can do is we can take the reciprocal of both sides, and essentially this will become p is equal to 1/5 minus 1 over q to the negative 1 power. Now, the reason why I can't just flip this 5 minus q is because I don't have a common denominator. So to make a common denominator, what I'm going to do is I'm going to take the common denominator 5q. Essentially, this will become q minus 5 in the numerator to the negative 1 power. Now that we have a common denominator, I can just flip this fraction, and this will become 5q over q minus 5. And now, if I have p equals 5q over q minus 5, I can take the derivative of both sides. So then I get dp dq is equal to 5. Okay, so I'm gonna write this as 5q. Actually, let's just use quotient rule here. Low d high, so low q minus 5 d high minus I d low, the derivative of the bottom is just 1, over low, so that's just q minus 5 whole squared. And on the top, we're going to get 5q minus 25, right? Minus 25, and then minus 5q over q minus 5 quantity squared. 5q minus 5q go away, and we get negative 25 over q minus 5 squared. So as soon as you realize that taking the derivative of both sides from the beginning doesn't work, you want to push it to the form in the answer choice, and that's why this right here, this right here is, oh, that's not what I'm doing. Okay. Oh.
So why did we have to P, like P on its own? Like, is there, like, if we see it again, would there be a reason that we have to do that on a question like this?
Yeah, I mean, sometimes, usually that's actually what you want to do. And that was my mistake. I didn't do that at the beginning. Why? What we did was explicit differentiation, because instead of creating an implicit function, we essentially solved for the explicit function.
Okay.
For example, okay, so some of them, there's a lot of here actually that you have to, it's easier to turn it into an explicit function than just do the derivative as normal, rather than trying to do the implicit differentiation. What I was trying to do was see if I can copy this and put it up here, but it doesn't really let me do. That's fine. I'll just box the answer right here. Negative 25 over. Okay. All right, anything else?
Can we work on what's the new plus called of derivative inverse functions? Can we just, like, I don't know, like, any questions? I'm still struggling on it. So maybe like what some of the
Like the inverse functions?
Yeah, I'm still struggling with that.
Sure, of course. Okay. Let me just go ahead and box this just so people can go back and see these later. Okay. So if we're looking at derivatives of inverse function, I'm going to use that here. Let's go ahead and make a line here. So we're doing derivatives of inverse functions. Oh, I cannot draw straight lines, as you know. So, okay. Let me see, look through these and think of a good problem to do. So I'm not going to do number 1 through 8 because that's just, using the rule and you can figure that out. Let's try. These are all actually pretty easy. And this one was a pretty short piece of homework. So let's try some of the ones from number 2. Look through number 2 and tell me which one you guys think is one of the harder ones, and we can do one of them. Zachary, Ghosh, Shruti, anyone? Kern? Have you guys tried doing the inverse functions problems yet? If not, that's okay. It's just, I was just wondering, that way we can try and address.
Can we do F?
Yeah, let's try 2F first. Okay, 2F. All right, so fx equals negative e to the minus 3x over x squared plus 1, correct? Okay, we're asked to find the tangent line to the inverse at the given point. So the given point is -1, 0, meaning that we're asked to essentially find f inverse prime. I don't know if this is the proper notation, but to me this notation makes sense. F inverse prime of -1. Do you understand this notation? I don't know if, I think some people write it like this, where they put F inverse and then they put I think this is the proper notation. I don't really know. To me, this on its own makes sense and I can get by it. So just, I guess, deal with that for now, hopefully. And then, okay, so what we want to do is we essentially want to be able to find a formula for f, assuming we don't memorize anything. We want to be able to find a formula for f inverse of x, right? So let's try two things. I know that I'm going to have to use the property that f inverse of f of x equals x. The problem with this is that I'm going to need to do f inverse. If I take the derivative of both sides, I'm going to get f inverse prime of f of x times f prime of x equals 1. But the problem is I don't get f inverse prime of x. Sorry, I should say f inverse prime of x. I don't get f inverse prime of x. I get f prime of x in terms of f inverse prime of x. So instead of using this formula, I'm going to use f of f inverse of x equals x. Does this make sense why I'm doing this now? Because now when I take its derivative on both sides, I get f prime of f inverse of x times the derivative of the inside function, which is f inverse prime of x equals 1. That means I know that f inverse prime of x equals 1 over f prime of f inverse of x. Okay, does this make sense, what I just did here? This is if you're trying to work it out on the spot. Eventually, you'll get to a point where you just know this off the top of your head, but I never, there's no point in trying to memorize it, if you get what I mean. So just try and understand this concept, and you'll be able to just use chain rule to figure it out, right? So now that we have our formula, I'm going to erase this stuff right here. Okay. And then I'll just write the formula up here, which is 1 over f, what was it? It was f prime of f inverse of x, I believe. Okay, so if we're given this, the first thing I need to know is if I'm trying to find f inverse prime of -1, that's equal to 1 over f prime, or sorry, not f inverse, f prime of f inverse of -1. What's f inverse of -1? What's f inverse of -1? Based on the what they give you in the problem.
0.
0, right? Because they tell you that -1 comma 0 is on the graph of f inverse. So we know that that's just 0. So now we're trying to find f prime of 0. Now, if we can just take the derivative of f of x, then we can find f prime of 0. Let's do that. So what is f prime of x? Let's just pretend like I'm just going to write in terms of x first, and then we'll plug in the 0 later. So let's just use chain rule. We'll have low x squared plus 1 d high. The derivative of the top is negative e to the -3x, but then we have to take the derivative of the exponent, which is -3. This becomes 3e. Oh, this becomes 3e to the -3x. So low d high minus high. So because we have a negative up here, I'm going to change that to a plus. Plus e to the -3x. D low times the derivative of the bottom, which is 2x, over low. The derivative of the bottom is x squared plus 1. But because I'm taking the reciprocal of that, I can just move x squared. I can just move x squared plus 1 to the numerator, and that'll become x squared plus 1 quantity squared. Okay, does this make sense where I am right now? Okay.
Wait, how come the x squared plus 1 went on top?
Yes, because f prime of 0 is all of this, using the product rule, it's all of this divided by x squared plus 1 whole squared. And since we were taking the reciprocal of it, 1 over that, I can just flip the fraction. So then I just put the x squared plus 1 in the numerator. X squared plus 1 whole squared. Does that make sense, Zachary?
Yeah.
Okay. All right. So now I can just substitute 0 in. So the numerator, we're going to get, so 0 squared plus 1 is what? 1 squared. So that's just 1. Right? And then 0 plus 1, so that's just 1. E to the -3 times 0, so that's e to the 0 is 1, times 3 is 3, so this right here is 3. e to the negative 3x. So if I plug in a 0 here, e to the negative 0 is 1 times 2 times 0, which is 0. So this is gone essentially because we have a 0 here. So we have that is equal to, this is equal to 1/3, and that should be your final answer. Is that the correct answer in the solutions? Let me just check my work just to make sure I got the same thing twice. Sometimes that just helps, just looking whether you got the same thing twice. Which one is this? Is this F? Oh, I'm sorry, that's not your final answer. That's the that's the derivative. Now we have to find the tangent line, right? Tangent line is easy because all you got to do now is plug it into the form. Y minus y1, well, that's just 0, is equal to 1/3 times x plus 1, because we have minus 1 here, and that is the answer. Oh, I don't know why that happened. Okay, good.
Mrigayu, I'm so sorry. I like zoned out. Could you re-say how you simplified the
This part right here?
Yeah.
Okay, yeah, so you just plug in 0, right? Because I wrote it in terms of x, so I could just, put it like that, but all you got to do is now you just substitute in the 0 here, the 0 right here, and then you just substitute that in everywhere you see an x. So 0 squared, okay, we're going to end in 10 minutes because I have another meeting to go to, but if I can maybe stay an extra 15 minutes, but we'll see. So you just plug in the 0 squared plus 1 is 1, 1 squared is 1. So I'm just doing the simplification. You can do this in your calculator. Try to not use your calculator whenever not possible, because it is an analysis class, and the more in an analysis class, the more you do things by hand, and the cleaner it is, because your calculator might not give you the best answer. Okay, so like I just plugged in 0 essentially. Okay, do we want to try another problem from inverse functions, or does this make sense? This is a very simple thing. I mean, it's really just once you realize that you can take the derivative like this right here is like your key. Once you understand this, then all you got to do is just plug the stuff in, and then you'll be good to go. Yeah, that's pretty much all it is. Any more questions? Moham, does this make do you understand? Okay.
Yeah, I do. Thank you.
Okay. What I'll try to do is I will try to either see if I can turn this into a PDF of a sort, or if I can. What I tried doing was I just shared this link, but my concern is that if I post this on the internet, then anyone in the whole world will be able to edit this, and I don't want that to happen. So I'll see if I can turn this into a PDF or something, or just take a screenshot of this. Okay. Any more questions? I just want to make sure we address everyone's concerns.
Okay, I have to leave. Benji, thank you so much.
Yeah, of course, no problem. Shruti, Karan, Gaushik, anything else? We good? All right.
Thank you.
Yeah, no problem. All right, good luck on the quiz tomorrow. All right. Bye, guys.